It is well established that chronic stress can have damaging effects on the body and mind. More recently, we've learned how stress from adversity early in life, in the form of poverty, racism, and other disadvantages, can produce physical and mental health problems in youth and shorten life expectancy. But much of the traditional research on stress has focused on either the brain, the immune system, or its effects on singular organs like the heart, despite evidence that these systems are interrelated. The NeuroImmune network hypothesis proposes a holistic perspective for how stress can generate risk for mental and physical health problems.
What we're suggesting is that by studying multiple organ systems, we can really understand the dynamic relationships between the brain and the body, and how life adversity can generate risk for such a broad set of mental and physical health problems.
Robin Nuslock and Greg Miller first proposed the model in a paper in 2016.
I think what's new about our perspective is that it integrates multiple lines of research that have happened in isolation of each other. And so what we're trying to do is create a synergistic model that brings together these different lines of research into a more comprehensive perspective.
In response to early life adversity, systems in the brain that process threats, like the amygdala, become very active and activate peripheral neuronal activity that modulate the immune system to prepare the body to manage stress.
It accelerates heart rate, it accelerates breathing, it suppresses digestion, all things to help people kind of manage stressful situations. And this is highly adaptive in the short term. It facilitates our ability to respond to life's stressors and slings and arrows.
But when stress is chronic in children, it can have long-lasting effects. One of the ways this happens is in early developing white blood cells. The stress response causes the molecule norepinephrine to be released onto these early cells that pushes them to overreact the next time they perceive pathogens. This increased cellular inflammation can then travel to the brain where it can modulate brain activity and then increase the neuronal signaling to create more response to stress in the periphery.
But when chronic, this can facilitate what we would call a positive feedback loop, where the two systems amplify each other in a way that over the life course can generate these kind of profiles of risk. We also have brain systems that are involved in facilitating rewards and helping us get up off the couch to go pursue the rewards that we want in our world and in our life. These systems center around midbrain dopamine and are essentially kind of the equivalent of the gas pedal in the brain. These are accelerator systems that get us to go get the rewards that we want.
But under conditions of inflammation, the inflammatory proteins in cells can reduce dopamine signaling in these reward circuits.
And this makes sense. One of the first symptoms of being sick from a cold or a virus is a feeling of malaise, low motivation, kind of disengagement. When you're sick, you want to conserve metabolic resources to fight off pathogens and heal from wounds. When chronic, now what we have is we have an inflammatory system in the periphery that actually can drive the brain into a profile that looks very similar to depression, elevated threat processing and reduced reward-related brain activity.
Another target of this inflammatory signaling in the brain is the prefrontal cortex, which provides so-called executive control to help us manage long-term goals over short-term interest and to engage working memory to pursue cognitive interests.
And chronic inflammation potentially alters the developing prefrontal cortex in a way that can reduce or kind of lower the brain's capacity to regulate its behavior. This then creates this profile of signaling between the brain and the body in a way that promotes this heightened inflammation and neurodysregulation in the brain. That's often distressing for a person. If a person is in a profile of heightened inflammation and has brain structure or brain activity that is very similar to depression. The final component of our model then is that a person would then engage in behaviors to regulate that dysphoria. And there are many ways that people can manage their stress. one of which is to engage in consuming high-fat diets, consumption of excessive amounts of alcohol, consumption of drugs, and all of these behaviors are what we would consider to be pro-inflammatory. That is, they can actually generate additional inflammation. And they can also have neuroplastic effects on the brain and change the very brain systems that we care about. So in a way, the behavior can become a fan to the fire that is signaling between the brain and the body in ways that can really create a lot of further problems in a person's neuroimmune network, but also can generate a lot of life stress in their world by engaging in high risk, unhealthy, and problematic behavior.
Scholars' work uncovering these processes is providing new evidence for how stress gets under the skin, but also ways of preventing the damage. Studies have shown that people with certain neural profiles around the prefrontal cortex are mostly protected from the effects of early life adversity.
There's also a lot of research coming from the University of Georgia in which it's been demonstrated that you can actually help train parents in ways to generate a supportive and nurturing environment for children, even in the context of exposure to early life adversity, that can protect the brain and body from growing up in early adverse environments. This has been now observed in the brain, in the immune system, in the functional genome, and in behavior. And that parental nurturance and a nurturing environment can really help protect the brain and the immune system from exposure to early life adversity. I think what our model is trying to do is to take what we would call a biosocial perspective. There's a lot of research suggesting that when people are feeling dysphoria, they regulate their dysphoria and distress and pain and sadness with various strategies, some of which can be unhealthy. There's a lot of research that focus on the signaling between the brain and the body under conditions of stress. But what our model is trying to do is to integrate that into a perspective that brings in the basic biology, but also brings in the behavioral component in a way that we think is more comprehensive and integrative.